Alright, in Geometry 2-7, we're getting into the proofs, the ones that the other class have tried to scare you from. Hopefully you can pick up on what we're doing here. If not, we can go over it in class. No worries, I'm more than prepared. But we're going to start slowly into the proofs. Hopefully the algebraic proofs were a little you could understand it, so that you can at least get the formatting, and then we just understand how to use this logic. And just remember that geometry is all basically, we're trying to figure out reasonings and logic to get from one place to another so that you don't make up any steps. So if you use logic, then you should be fine. Segment addition postulate, so we're going over some proofs. So a lot of times now, as we're going through it, you're going to do more and more complicated proofs. So I'm going to give you more of, let's say, ammo, okay, in order for you to get to have the correct reasoning. So all these proofs and postulates that I'm giving you are reasonings to why you can do certain things. So the segment addition postulate is saying that if AB plus BC equals the entire thing, then I can say that B is somewhere in between A and B. I mean A and C. What was I thinking? Right? And the segment congruence is basically, we're going to do a little review on what you saw in the other properties from the other section. But reflexive, if you remember the reflexive from 2-6, it basically means something equals itself. In the other ones we had a point, in this case we had a line. So if we have AB, line AB, then the reflexive symmetry says that AB looks in the mirror, then it'll see itself, AB. So reflexive is AB equals AB. The next one is symmetric. And that's the one, remember, where on the equal sign you can take it and flip them. So if I have AB, line AB, equals line CD, then I can say that CD also equals AB. I can flip it. Transitive is the one where we're talking about different heights of different people. And so if AB equals CD, right, and then if I say that CD equals EF, then it basically means they're all equal to each other. So I can also take out CD and make what? AB equals EF. And that's another an important one that we're constantly using, is a transitive property. So go ahead and write this down, and we're going to go into the examples. We have 2 examples. And don't forget your vocabulary. Okay, so this one is an example. It gives us, given PR equals QS, prove that PQ equals RS. And I believe that there should be a picture to this. Sorry. I need to draw you this picture. Wow. So the picture is PQ and RS. Alright, so it says here that the given is PR, this whole thing, equals QS. And it wants you to prove that PQ equals RS. So what I'm going to do is I'm going to separate the picture a little bit so you can see. So there's this line called PR, and there's a Q here. Okay? And it's equal to this line, QS. So I took this and I split it. I split it into these 2 so that you can see a little bit. Basically what it wants me to do is it wants me to prove that this and this are equal. Now, again, it's a little bit easier if what you do to not overwhelm yourself is just try to figure out, like, how am I going to get from that place to another? I don't get it. I don't understand. Don't do that. Just take it step by step. See what you can prove, and then little by little what you're going to do is you're going to give yourself clues. If you try to just step back and say, okay, how am I going to answer, I don't even know where to, what is asking or anything, don't. Start with what we always start with. What do we always start every proof with? And that's the given. Okay? So my first step is to do the given, which tells me that PR equals QS. So this whole thing, this whole line, right here, equals this line. So PR equals QS, this is my given. So from there, let's see if we can figure something else out. We know that PR equals QS. Okay? We also know that there's these dots here. So let's do PQ plus QR equals PR. Remember when we had here, most of the time they're going to use proofs with postulates they're introducing. So they introduced us the segment addition postulate. So why not why not try that? Okay? So AB, it says AB plus BC equals AC. So what it's saying is PQ plus QR equals the whole thing PR. So what else can we say? Well, we can say the same thing about the other line. We can say that QR plus RS equals QS, right? And again, which postulate did we use? We used the new one, which was the segment addition postulate. Okay, segment addition postulate. Now, let's look at what they give us. They tell us that PQ plus QR equals PR. They tell us that QR plus RS equals QS, and they say that PR equals QS. Well, when things are equal to each other, then you can substitute them for anything, right? So anywhere I see PR, I can also QS. So instead of PR here, what else can I put? QS. Instead of QS, I can also put PR. So what if instead I put PQ plus QR equals QS? See that? So PQ plus QR equals, so I put the same exact thing, but in this case, instead of PR, because they're equal, I put QS. So what reasoning did I have for that? In that case, I substituted, so I used substitution. All right? Now, the next step here, I'm going to now focus on these two right here, these last two. This equals this, and this equals this. They both equal what? QS. And remember how we were having the segment congruence right here? Well, the segment congruence says that if they're equal to the same thing, then they're all equal to each other. And I can take out what they have in common. So what can I take out here? I can take out QS. See that? And I can make, on my last one, I can make QR plus RS equals this whole thing, PQ plus QR. You see that? What did I do here? That was a transitive property. So again, what I did was because this equals QS, and because this equals QS, I just made them equal to each other. Now my last step, okay, well, you might not know it's your last step. I know it's your last step, so I apologize for saying it. But our next step would be to see what they have in common. Well, this has positive QR and positive QR. So if I subtract QR from both sides, I end up with RS equals PQ. Do you see that? Because I subtract QR, that cancels out. Subtract QR, that cancels out. And I end up with RS equals PQ. Alright? So my next one, what did I do? I subtracted. And since this is PQ equals RS, I can easily switch this. Sorry. I can easily switch this and say PQ equals RS, because if I just switch the whole thing, what is that? That is the same thing as saying symmetric. Now, if you just stop here, I wouldn't mind, because RS equals PQ is the same thing as PQ equals RS. The important thing is you understand these steps right here and how I got from here to the last two steps. So go ahead and try it, page 121, number 1. It's going to set up most of it for you, and you're just filling in the logic. And then we'll have one more problem to go to. So page 121, number 1. Okay, so our last problem is number 2, and basically, first and foremost, what are we going to start with? We're always going to start with our given. So the first one, and we're going to write them. There's 3 givens, 1, 2, 3, so I'm going to write them all. WY equals YZ, YZ equals XZ, and XZ equals WY. So basically all of these are equal to each other. You see that? And what it wants me to prove is WX equals WY. How does that work? Did I label it right? Sorry, these are supposed to be changing. My apologies. Okay, so basically we're going to prove that WX, so this equals WY. So this has a lot of them that are equal to each other. And again, my reasoning for these are all given, 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 and given. Okay? So on this case, my next step is try to see if I can start relating them. Because right now, we have WY equals YZ, YZ equals XZ, and XZ equals WY, but we don't have WY and YZ related to each other. I'm sorry. This is supposed to be WX. I just keep messing up. Okay. So, again, just like the other section, it's going to be overwhelming for you to try to figure out how to get from here to here. What you want to figure out is just little steps, okay? You might do the wrong one. It's alright. Just leave it in there. You don't have to erase it. But just keep giving yourself steps and clues so you can see what might fit together so that you ultimately get WX equals WY. So let's try this. WY equals YZ and YZ. So let's focus on only these two for now. What do we see about these two? They have something in common. What is that? It's YZ. And when something is equal and has something in common, what can we do? Well, we can take that out, right, and end up with WY equals XZ. Why can we take that out? Well, remember when we were talking about height and we're talking about common things? This is called the transitive property. Remember, I'm telling you, we're using this a lot. So this is the transitive property. The next one, now let's focus on the other two that they have, which is these two right here. Okay? Now on this one, it's very similar in the other one. You have, is this right? WY equals X, yeah. We have something in common. They might not be on the same places, but we know that XZ equals WX, and we know that WY equals XZ, but they both equal which one? XZ. So we can go ahead and take out XZ, and what do I end up with? WX equals WY. So WX equals WY. This is also, the same thing we did here was a transitive. And if you see, this is the same thing as this. So without even seeing, just using those steps, we ended up from the given to the proven. So just like I said, sometimes you have to take it just baby steps, just little steps, and give yourself clues. And you end up with what you wanted. They set it up in that kind of way. And remember to use the properties that they give you. So try page 121, number 2. This one, they don't have set up with you like number 1. But let's see if you can get it. If not, bring it to class and we can do it together as a class. But hopefully that's understanding. You can understand it and that you do your vocabulary. I'll see you tomorrow.